Hi, everybody, welcome to Math with Ace. We are focusing on statistics and we are continuing our journey into inference. We have been dealing with hypothesis testing and confidence intervals for one sample. We're moving into two samples. And the main thing you want to think about is when you are presented with a question, you should ask yourself, am I being asked to perform a test or create an interval? Do I have a question about one or two samples? And am I talking about means or proportions? And so if you're asked to create an interval or estimate a parameter, that's a confidence interval. And you run through the confidence interval process. If you're asked to test a claim or perform a hypothesis test, that is a test. Then if you have categorical data where you have successes and failures, that is about proportions. If you have numerical data where you have a list of numbers or you're given mean and standard deviation, that is about means. And then if you have one group of sample data, that's one sample. And if you have multiple groups, that's two samples. So this question asks us it says, a research study was conducted about gender differences regarding the use of seatbelts in motor vehicles. The researchers believe that the proportion of men not wearing seatbelts is more than the proportion of those who were not men wearing seatbelts. The data collected represents a random sample of U.S. adults and is summarized in the table below. Is the proportion of those who are men not wearing seatbelts more than the proportion of those who are not men not wearing seatbelts? Use the four-step process to perform a hypothesis test at alpha equals 1% level of significance. Now, men versus not men, I realize not is in this sentence a lot, but I'm trying to just categorize two people in a binary sort of way in a place that might not be binary. So we're dealing with men versus not men. And this asks us to perform a test. So we're doing a test. It does talk about the proportion, those who wear seatbelts and don't. That is categorical. So this is a proportion problem. And we have two groups. We have men versus not men. And so we're going to start off the same way that we do, where we are going to identify our hypotheses, we're going to define our level of significance, and then we're also going to identify our parameters and context. So for our statement, we want to perform a test. And I like to say at alpha equals 0.01 level of significance on, and then our hypotheses. This is about proportions, and please note that our statement of equality is always the null hypothesis. And we're talking about men versus not men. So I could say P1 and P2, or I could say PM and PN. So I'm going to say PM and PN, and they're equal in our null hypothesis, but our test is are men not wearing their seatbelts more? So men is more, which means that PM is more than PN. We could also write that as PM minus PN equals 0, and PM minus PN is greater than 0. Both of those are acceptable ways to write your hypotheses. We're going to pause to let that show up. Now we need to identify our parameter and context, or parameters and context. So where PM it's the true population proportion of and this is the men not wearing seatbelts. And then PN, let me scroll down just a little bit, is going to be not men not wearing seatbelts. Pull this over a little bit. Okay, now we've stated what we're going to do, but the important thing to do next is check our conditions and make sure it's okay for us to go ahead and perform calculations. This is our plan. Remember the conditions we checked. Was it random? Was it independent? Can large counts be met? So it does say that, let's see, research study was conducted. The researcher believed the data collected represents a random sample of US adults. So it was randomly collected and they categorized them into did not wear seatbelts or into men versus not men and then collected there. So we will say that the data collected for the two groups was random as stated in the problem. Okay, and this was our random condition. What about independent? Well, the sample size for men was the sample size for men was 2,231, and the sample size for not men was 2,169 from the table. Okay. That means in order to be independent, we need to multiply both of those by 10. So 2231 times 10 is 22,310. 2169 times 10 is 21,690. So this is talking about all of the United States. This was in general, we were talking about a research. So it's safe to say that there are at least 22,000 men and 21,000-ish not men. There are a lot of people in the population, so that's a safe bet. Lastly, we need to check the large counts. And remember, at this point, we don't have a hypothesized value that we can use because we're just assuming that they're the same and trying to say that they're not, or we're trying to test that one is greater than the other. And so in this case, we have to use our sample successes and sample failures in order to be able to run the calculations. So first of all, we had for, let's see, we need to test not men sample size times the proportion, men and not men. And we need to take the failures as well for both. So successes and failures from the sample. We were told that there were 2231 in the sample size for, let me do it in a different color so you can see. Let's say blue. So N of M above was 2231. So 2231 times. Now we need how many successes there were. There were 183 who did not wear seatbelts, and then the remainder who did. The sample size for not men was 2169, and there were 156 out of those that did not wear their seatbelts, and then the complement. So that means that for our successes, we have 183, which is at least 10. We're good there. And this one is 156. We're good there. So successes for both men and those who were not men were both over 10. That's great. Well, that means that the remainder of the 2231 are our failures. So that's 2,048 because 2231 minus 183 is 2248. And then for the 2169, if we take away 156, we have 2,013 failures. So successes and failures for both groups were at least 10 and were safe to proceed. Conditions have been met. Now, in order to go ahead and perform the test, calculate the test statistic, the Z statistic, we need to pool our proportions first so that we can perform the calculation. So if you remember, the pooled formula was to take the successes from men plus the successes that were not men over the sample size of men plus the sample size of those that were not men. So let's scroll down just a little bit. There were 183 who didn't wear their seatbelts of the men, 156 of the not men, and there were 2231 men plus 2169 not men. So 183 plus 156 is 339, and 2231 plus 2169 is 4400. So if I divide the two of those, I get 0.077. So our pooled proportion, when you take 339 over 4,400, you get 0.007. Our Z statistic was found by taking the difference in the statistics. So P hat 1 minus P hat 2, and then you subtract away the hypothesized values, and then you're dividing that by the pooled and its complement, and then you're multiplying that by 1 over the first sample size plus 1 over the second sample size, all underneath the square root. But remember, we're not using ones and twos, we're using men versus not men. So all of the ones are men's, and all of the twos are not men's. And so we're going to use those numbers. There were 183 out of 200 or 2,231 minus 156 over 2,169. We are hypothesizing that there's a difference, so we're subtracting 0 here. And we are dividing that by the pooled proportion of 0.077, and then 1 minus 0.077, and then 1 over the first sample size plus 1 over the second sample size. Okay, so if you want to do 183 divided by 2231, that is roughly 0.082, and 156 divided by 2169 is roughly 0.072, which when you subtract those, you get a difference of 0.01. So our numerator is 0.01, and when you divide out the denominator, you get roughly 0.008. So 0.01 divided by 0.008 gives me 1.25 roughly. Okay. So next what we're going to do is we're going to go ahead and calculate the probability of being more than that z-score. Because if you go back to the null hypothesis up at the top, our null hypothesis was that men was greater than not men. So we are doing a greater than test, which means the way that our z-score was set up, where men was first, we need to be greater than 1.25. Now, z-score of greater than 1.25 isn't really that rare. But if you look at a drawing, when we have our z-score, we are assuming that there is no difference. And now we're trying to figure out about what's the probability of being greater than 1.25. So if we went to our normal distribution, and we entered in a mean of 0 and a standard deviation of 1 because we use a standard normal distribution, probability of being to the right of 1.25 is roughly 10% or 10.56%. So the p-value is 0.1056. What if I wanted to perform inference? I could go into Stapplet and I could do one categorical, multiple groups, but I would need to say, I'm going to make this bigger. Group 1 was men, group 2 was not men. The category was not wearing seatbelt. There were 183 who did not, and 156 for the second group. And then wearing seatbelt, so you have to enter in the table. There were 2,048 versus 2,013. And we begin analysis. Down at the bottom is where we see our inference. And we want to perform a test. Our test, because we entered men first, our test is greater, and we are talking about not wearing a seatbelt. We get a p-value of 0.1045 with a z-score of 1.256. This is because the computer does not round, and we do. But we are very close. We get the same thing. So now what we're going to do is we're going to draw our conclusion. And our conclusion is that our p-value compared to our 1% level of significance, it's not really that small. So since our p-value of 0.1056 is not less than our alpha equals 0.01 level of significance, not less, don't reject. We fail to reject the null. What does that mean when we fail to reject the null? That means we don't have evidence for the claim. What was our claim? That's the last thing. Our claim, the question asked us of whether the proportion of men who don't wear their seatbelts is more than those who are not men. So we do not have evidence to support that men are not wearing their seatbelts more. Okay. Now you've seen how to perform inference for two samples for proportions as well as means, and you've seen how to test a claim that has a two-tailed test versus a test that is one-tailed. So hopefully this was helpful and you are able to master the topic. Thanks for watching, everybody.